In the early hours of November 10th, an anonymous post on the Chinese platform Weibo sent ripples through the international astronomy community. What appeared to be an innocent image dump turned out to contain something far more significant. Unreleased visuals from the Tianwen-1 spacecraft, showing detailed frames of 3I Atlas near the orbit of Mars. There had been no official press release, no scheduled announcement, yet here it was, calibration markers intact, full metadata, and raw spectral overlays, exposing an object that has defied scientific expectations since its first sighting in July. Within hours, image analysts confirmed the material's authenticity. There were no signs of tampering, and the formatting matched internal CNSA processing tools. What these images revealed wasn't just new, it was paradigm-shifting. From directional ion trails to suspected brightness modulation bands, the leak suggested a hidden layer of structure and motion. What could have prompted such a leak? Was it a mistake from a junior data handler, or something far more calculated? This wasn't just a breach of protocol, it was the acceleration of discovery. If accurate, this leak marks one of the first times in history that classified interstellar data reached the public before the researchers could even analyze it. And more importantly, it changes what we thought we knew about 3I Atlas. Let's walk through every detail, calmly and clearly, as we try to understand what this anomaly is telling us, not just about the object, but about how the universe might communicate when institutions stay silent. Because truth, once leaked, can't be taken back. At 2:13 a.m. Beijing time, on November 10th, an anonymous account uploaded 5 high-resolution images to Weibo under a generic caption, Mars camera testing. What might have passed as routine tech content was instantly flagged by a handful of amateur astronomers across China, who noticed something strange about the calibration data in the image footer. It wasn't formatted like Earth observation data. It resembled deep space orientation protocols, used during asteroid or interstellar tracking. The images themselves were unusually crisp. Frame 1 showed a faint green object with a defined nucleus, framed against a backdrop of dim Martian orbit. Frame 2 revealed the start of a faint emission trail, but it wasn't the visuals alone that triggered the uproar. It was the embedded orientation metadata, field of view alignment, exposure levels, and timestamps consistent with Tianwen-1's orbital parameters. Within 45 minutes, the post was deleted. The account went offline. But in that brief window, the images had already spread to Telegram channels, astronomy discords, and finally Western forums. Image recognition tools confirmed it. This was not synthetic. It was a real probe capture from the Chinese spacecraft Tianwen-1. The strange part? No one had publicly stated that Tianwen-1 was observing 3I Atlas. In fact, China had been quiet about the comet for weeks. The idea that this data was uploaded accidentally is, in itself, a massive claim. But if deliberate, the implications are even deeper. Someone inside the system wanted the world to see what Tianwen-1 had captured, and now that we've seen it, we can't look away. The leaked images don't just show a comet, they show a shift in intention. Tianwen-1 was never designed to observe deep space interstellar objects. Its primary mission was to orbit Mars, collect terrain data, and assist ground rover operations. Yet, the photos tell a different story. Embedded orientation logs reveal that the spacecraft had reoriented its main payload toward the far outskirts of Mars' orbital envelope, targeting a moving object that didn't belong to the solar system. This maneuver wasn't accidental. To aim at 3I Atlas from Mars, engineers would have had to reprogram pointing instructions days or even weeks in advance. It takes precision, not just to track a hyperbolic trajectory, but to hold exposure long enough to capture useful data without signal bleed. So why did Tianwen-1, a Martian orbiter, suddenly become a deep space observer? One theory is that Chinese scientists, having studied early data from NASA and ESA, suspected something unnatural about 3I Atlas and quietly repurposed their instruments. But another possibility is more intriguing. The maneuver was authorized in secret, but the leak wasn't. What this confirms is that someone inside China's space infrastructure knew exactly where to look and what they were looking for. The level of image stabilization, the calibration precision, and the multi-exposure layering suggest this was not a test. It was a mission. For a spacecraft not publicly scheduled to observe anything beyond Mars, Tianwen-1's camera pointing raises a fundamental question. What did China see? that compelled them to look deeper. The most visibly stunning element in the leaked images was not the nucleus or coma, but the direction of the tail. Typically, comet tails stretch in the opposite direction of the Sun due to solar wind pushing out gas and dust. But in this case, the images captured an arc, an emission plume subtly curving toward the Sun instead of away. This is not how physics is supposed to work. There are only a few plausible explanations. 1. Electromagnetic interference so strong that it bends the ion tail back toward the source of solar radiation. 2. Directional emission, jets being released from within the body in a controlled arc. And 3. We're seeing a visual artifact, a misinterpretation caused by angle or timing. But the odds of such a consistent tail orientation in multiple exposures suggest the arc is real. This detail stunned Western astronomers. It suggests one of two things. Either the solar wind is being deflected unnaturally around the object, implying an electromagnetic envelope, or the emissions are being controlled internally to arc in specific directions. Either outcome breaks standard comet models. If the tail is moving toward the Sun, we are no longer looking at passive sublimation. We're observing behavior, a system that outputs energy in a patterned, perhaps guided fashion. This is why the leak matters. This isn't just a better image, it's a new chapter in how we think comets interact with the environment, or how they might alter it deliberately. Across multiple leaked frames, analysts discovered a subtle but repeating pattern, alternating bands of brightness across the coma of 3I Atlas. This wasn't a visual glitch. It was embedded in the raw light data detected using histogram analysis and frequency filtering. The spacing of these bands, measured at roughly 3.5 arc-seconds apart, remained consistent in at least 4 separate frames, suggesting a repeating event or physical structure. In natural comets, brightness gradients are usually chaotic, affected by spin, sublimation, or irregular gas outbursts. But here, the modulation appeared rhythmic. One plausible explanation is that the comet is rotating, with periodic jets briefly illuminating certain areas as it spins. But that alone wouldn't explain the clean, symmetrical brightness banding. Another possibility? Pulsed emissions, small, timed ejections of material that increase the coma's reflectivity in intervals. When brightness changes occur in regular cycles, scientists usually suspect 2 sources: rotation or intent. If the object is emitting energy or material at a steady interval, it implies internal timing, either from a natural resonance system or something engineered long ago. These bands are not seen in images from Earth-based telescopes, likely because the visual clutter and atmospheric distortion filter them out. But Tianwen-1's orbital view, free from such interference, captured them plainly. Brightness modulation of this kind has never been recorded in any known comet, natural or artificial. It adds one more anomaly to a growing list, and one more reason why the leak wasn't just visual excitement, it was a scientific detonation. One of the greatest mysteries about 3I Atlas is how intact it appears to be. Based on data from NASA and ESA, scientists believed the object was shedding material at a rate of up to 50 billion tons per month. At that pace, it should be fragmenting, cracking open like Shoemaker-Levy 9 did before its collision with Jupiter in 1994. But the leaked Chinese images tell a different story. Despite the presence of powerful jets and a wide, glowing coma, there are no visible fragments surrounding the nucleus, no secondary nuclei, no trailing debris clouds, nothing. Researchers immediately applied advanced filtering techniques to the leaked images, false color inversion, contour mapping, and ring differential brightness testing. Still, no signs of breakage. The core of 3I Atlas remained sharp, undistorted, and completely whole. This absence of fragmentation points to a rare form of cohesion. Either the object is denser than expected, unlikely for a comet, or it possesses some internal structure reinforcing its body. Could cosmic rays have altered its chemistry, forming a shell-like crust that holds it together? Or does it point to the possibility of a structured interior, compartmentalized chambers regulating internal pressure? The math doesn't lie. A comet this small shouldn't survive this level of outgassing, and yet here it is, untouched by stress, holding shape and releasing material in vast quantities. This is not the behavior of a natural ice ball, it is the behavior of something designed, or something so old and rare that we've never seen its kind before. Spectral overlays decoded from the leaked images show an unexpected feature: distinct reflectance spikes in the nickel and magnesium bands. These elements are rare in comets and typically associated with high-energy environments or engineered alloys. When astronomers performed spectral backtracing from the raw photo data, they reconstructed emission lines that lined up unusually well with those of metallic compounds. Nickel is known to reflect in certain ultraviolet bands, while magnesium responds to both visible and near-infrared frequencies. Here's the problem: these metals are not typically found in frozen objects originating from deep interstellar space. Comets tend to be composed of volatile ices, dust, and silicates, not refined metal clusters. So why does 3I Atlas show hints of reflective metals? One possibility is that long-term cosmic ray exposure transformed parts of the surface into metallic residues. Another, more controversial theory is that the object contains remnants of alloy plating or internal structural linings, like a degraded spacecraft hull or a fossilized probe left adrift for eons. NASA's early observations had hinted at high reflectivity inconsistent with pure ice. But the Tianwen-1 leak adds another piece of evidence. The concentration of nickel was strong enough to be picked up without direct infrared scanning. This is where the line blurs between comet and construct. Either 3I Atlas has a composition we've never seen before, or it carries the materials of something built,